Fest in October. Delighted to be here. My name is Rick Borup. Since '93, I've been working full-time in Foxborough and own and operate a company called ITA, specializing in um, line of business solutions for small and medium-sized businesses. Again, like many of you, I got started with Fox back in the early '90s, picked up SQL Server in the late '90s, and back when certification was possible, I was able to pick up a couple of those and to collaborate with some folks on a couple of books. Gosh, it's been a long time since we published any new books, but uh, really happy to have been able to do that. So here's what we're going to explore today. We've got 4 sections, and I will uh, try to pause for questions at the end of each section if we have time. So when we get there, we'll see how we're going. We're going to talk about the basic workflow with Git to get started. For those of you who use Git already, this is going to be a review slash refresher. I would encourage you to stick with it because I'm going to try and set the framework for the type of workflow that I'll be using in the demonstrations. And also, I've sprinkled a few tips and tricks into the presentation in all 4 sections along the way. So hopefully you'll pick up something new as we go along. Although it's not in the title of the session, I am going to spend some time talking about the VFPX Project Explorer by Doug Hennig, which is just a wonderful tool, a replacement for the VFPX Project Manager, and not an extensive deep dive into that by any means, but at least an introduction by way of saying that if you're not using it or you're not aware of it, I think you certainly owe it to yourself to know about it. In the 3rd section, and probably the bulk of the presentation, I'll be talking about the Sourcetree, which is a Git graphical user interface from Atlassian, and specifically how to use it with Visual Foxborough and Git. And finally, we'll wrap up in the last 10 minutes or so with some ways to get into trouble and how to get out of it. Uh, Git is very powerful, but it's also very complex, meaning that it's not that difficult to get into trouble. And sometimes you just kind of throw up your hands and wonder how you got there and how to get out of it. So I hope in that section we'll be able to shed some light on a few of the things that can commonly happen. So let's get started with the basic workflow using Git. The fundamentals, again, review for most of you here, I'm sure. The local repository exists on your local machine. The Git commands that we use in the local repository are committing, which adds a snapshot of the current state of the software to the local repository. Branching and merging are the fundamental concepts there. Creating a branch allows you to diverge from the mainline development, do your work, and then later to merge it back in. And the local repository, of course, is the .git folder under your root project folder. The remote repository, on the other hand, typically lives in the cloud. It doesn't have to be in the cloud, but it has to be on a shareable or at least an accessible location, shareable if you're on a team. And the Git commands that we work with on the remote repository are pushing, which you typically push your changes up to the remote when you're ready, and pulling, which is the flip side, you pulling changes back down from the remote into your local, and fetching, which is kind of a subset of pulling. A pull is really a fetch and a merge. I don't think we'll have time to go into fetching explicitly, but it is there and it is on the toolbar in Sourcetree, so you'll be exposed to it there. I wanted to just mention the workflow briefly that I'll be using here. In an earlier session, a couple of 3 years ago, I talked about different categories of workflows. The one that I'm using here today is called the feature branch workflow, and it's characterized by all development work being done on a branch. And then when at some point when ready, pushing the local branch to the remote. The feature branch workflow uses pull requests to share changes. It has some advantages and disadvantages. The main advantage is that it separates development from production. And it facilitates code reviews in the sense that when local branches are pushed to the remote, others can look at them there, or at least at the point where a pull request is created, then the reviewer and possibly others have the opportunity to review the code before it gets merged into the production code. The main branch is always quote unquote bug free. As we know, software is never bug free, but the idea there is that the main branch is reserved for code that has been tested and approved for production, as opposed to containing any work that is in progress or still in development. The disadvantages of this workflow are that it does require discipline to adhere to the protocol. All development has to be done on a branch. You have to create pull requests. You have to pull from main to get code back into your own local repository. And of course, pull requests require approval by somebody. It could be yourself. In some organizations, there might be a maintainer or certain designated individuals who are the only ones who can approve, and merge pull requests. So let's take a quick walkthrough of how that works. On the local machine, we've got the main branch, again, which will be our production code, and we have development or feature branches. A development branch does not have to be a new feature. Could be something as simple as a quick bug fix. It could be a minor addition, or it could be an entirely new feature. That's just a terminology, a feature branch in this particular workflow. So down there on the left, we have Alice. She's working on her local repository, starting at the bottom of that picture there. She's working on her laptop. She's running Git. She's running Foxbro. She's got a main branch in her local. And for the sake of illustration, she has two branches that she's working on, maybe simultaneously. Maybe she's done with one, start work on the other. But in any case, in her local, at this point, she has two branches. At the same time, Bob, our other developer on this team, is working on his local repository. He's on his local machine, running Foxborough, running Git, and he's working on his branches. Just for sake of terminology, so they can be different, we'll call them branch 3 and branch 4. Branches typically would have a meaningful name, possibly including a task number if you're using a Kanban or some kind of project management tracking software. But in any case, at this point, there's essentially a barrier between the two. Not physically, but both of them are individually working locally. Nothing that they're doing is affecting the other one at this point, unless they choose to share it in some way. But the idea is that this is all local for both developers on the team. As Visual Foxborough developers, we have some special considerations. Fox, as we all know, requires that we use binary files. And binary files can't be what's called diffing, or seeing the difference between two files is a key part of Git because it's how you can resolve merge conflicts. But you can't diff binaries. So, of course, we create text equivalent files using Fox bin to PRG or 2Fox perhaps. And regardless of how we do it, the question then arises, what do we commit to the local repository? And we have three choices: just the binaries, just the text files, or both. All three are valid in different developers have different approaches. Binary files only is okay, except that you have to then regenerate the text files in order to do any comparison between two versions. Text files only has the advantage of keeping the repository smaller because the snapshots that are committed to the local repository are essentially zip files. They're compressed, and binary files don't compress very well. So if you do include binary files, that's going to increase the size of your repository. If you commit only the text files, your repository will remain physically smaller, not to mention fewer actual objects being committed. But the downside there is that you have to regenerate the binaries before you can work on anything in VFP. The third option, committing both, is kind of the safety approach. It does contribute to larger repository size, but it also provides a backup in the case that, I should say, in the very rare case that might happen, if the binary could not be regenerated from the text file and you don't have a backup, then if you're not committing the binaries, you don't have any way to get back to them. So that's the choice is really up to you or up to your organization of how you want to handle that. Along the same line, Git requires commit messages. They become part of the commit ID or the hash that is created from every commit. And because they're part of the hash, they can't be changed other than by amending the commit, which we'll talk about a little later. A commit message can be one or many lines, typically just one line that's kind of a brief description of the why or what's being done. However, there is a nice discussion at the link that I'm showing on the slide here. That's also in the white paper. It goes fairly extensively into how commit messages can be structured, even going into multi-line, subject body type of things, which is a good way of doing a little more extensive documentation in your commit messages. After deciding what to commit, we have the question of when and how often to commit. And I always like this metaphor here to think of commits as stepping stones. So as you approach the end goal, which is going to be in this workflow a pull request, you have stepping stones along the way. How many of those you create and when you create them is kind of up to you. Again, your organization may have guidelines on how and when to commit. Probably committing every single little file change is overkill. Waiting until the end of everything and committing a whole bunch of files at once is probably underkill in the other direction. So I like to commit when I reach a point that the code is working, even if it's not a complete change to that feature. At least if I'm changing a visual class library or a report or something, once that part is working, that might become a commit. So that's when and how often to commit. Along this lines of committing, of course, there are files that you don't want to commit, and there's this, as I'm sure you all know, the .git ignore file, which allows you to exclude things that you never want in the repository, temporary files, zip files, executables, and so forth. The git ignore file is usually committed to the repository, and that means that it's shared by all developers, and therefore it affects everybody on the team. So if, for example, Alice adds an entry to git ignore and then pushes that up to the remote and Bob pulls it down, his git ignore is updated as well. So if there are files that are universally to be ignored, that works fine. But if there are files that are local to the individual developer, then there's another way to exclude them, and that's called the exclude file. It lives in the .git/info folder. It doesn't have a file extension. It's just called exclude. It's a text file, and you can think of it as a local exclude file. It is not committed to the repository. It's not shared with other developers, and therefore it affects only the local developer. It looks like this, and Git creates this when the repository is first initialized. The first 6 lines, which are comments, are provided by Git. The 7th line I added just for the sake of illustration. If in my own work I wanted to exclude all the files that end in .foo, I could simply add that to the exclude file, and then Git is going to ignore them on my local machine, but that won't affect anybody else. So if Alice ignores .foo and Bob wants to commit them, uh, the local exclude file will not stop him from doing that. So that's one of those things that maybe not everybody knows about, that local exclude file. So let's talk about the remote repository a little bit. Again, it is typically in the cloud. In a team environment, it has to be shared, and a shared remote is necessary for team development. It could reside anywhere that's accessible by all team members. The cloud, typically, because there are good hosting services like GitHub and Bitbucket, and because for geographically dispersed teams, it makes sense to have it not linked uh, other than through the cloud. There are advantages to using a remote repository if you're a solo developer as well, partly that it exists as a backup. There are other advantages as well that I'll talk about later. So what's on the remote? Well, the remote has a main branch. Again, that's in our scheme, in our workflow, that's going to be the production code. And then the remote will have local branches, or will have branches that are pushed from local branches to the remote. And from the point of view of the developer, these become what are called remote branches. If you log into GitHub or Bitbucket and look at the remote repository, you'll just see them as branches. But from the point of view of the local developer, they're remote branches. And along the same lines, there are what are called remote tracking branches that exist in the local directory. So when a local branch is pushed to the remote, it creates a branch on the remote. It also creates a remote tracking branch in the local. And that becomes important for a couple of reasons that we'll also try and touch on later on. So let's see what the workflow looks like. We have Alice here again. She's working on her local repository. She's doing some work. Let's say she's working on branch one. And at some point, she gets done, at least reaches a point where she's ready to push that branch to the remote. So she does that. And now the remote repository not only has the main branch, but it has a branch called branch one. At the same time, in Alice's local repository, a remote tracking branch is created. The word origin isn't special, but it's Git's default name for a remote repository. And so the branch is called origin slash branch one. Bob, on the other hand, is working on one of his branches, let's say branch three. So as you can guess, when he's ready, he pushes branch three to the remote, and now the remote has both branch one and branch three. And Bob also gets a remote tracking branch called origin slash branch three in his local repository. So the end result is that these two branches on the remote are linked to the corresponding remote tracking branch on the local branch of the local repository from which they were pushed. And those are kept in sync, which again becomes important for a couple of reasons. You don't typically see those in your work. In fact, you can kind of ignore them, and that'll come up again when we talk about Sourcetree. But they do exist, and that's an important. It's important to know that they are there. At this point, we're not yet working with Sourcetree, so we're sort of talking about command line Git, and so you can see the remote tracking branches if you type git branch dash dash all, which will show first the local branches with the one that's currently checked out being in green with an asterisk, and then the remote branches, origin branch one in this case for Alice, and of course a head branch, a head pointer, and a main branch. And then Bob would have the same thing, except that in his case, he has a remote origin branch three because that's what he pushed. So that's a little bit about remote tracking branches. So beyond the question of when and how often to commit, we have the question of when and how often to push. I've always liked this slide, a little bit of humor there, but it does emphasize the importance of committing and pushing. My take is to favor pushing more often than less often. I think at least once or twice a day makes sense, sometimes more often. In your workflow, you're probably going to get to logical breakpoints or at least physical breakpoints where it's time for lunch or whatever. And that's probably a good time to push to the remote, not only because it keeps the remote in sync as much as possible, but also because it's a backup. So if you do a whole day's work or an entire morning's work and then leave for lunch and something happens to your local machine and you can't get at it when you get back, you've lost that work. Whereas if you push it, at least it currently exists on the remote and you can get it back that way. So again, I would tend to favor or suggest you consider pushing more frequently than less frequently. A little bit about branching in Git uses what's called a short-lived and long-lived branches. Short in this case does not mean that it's limited to existing for only a certain amount of time. It means that it's not permanent. Um, and so in some cases, a short-lived branch could exist for a long time. I in fact have worked with some that have existed for several weeks, even gone into several months. That's not only in the case of a long development cycle, but also in situations where you might start work on a branch and then Another priority comes along and you have to set it aside and then come back to it later on. And in the interim, the branch continues to exist, even though it's not intended to be a permanent branch. And of course, by contrast, long does imply permanent. In the workflow that we're talking about, the main branch is a long lived branch by definition. It never goes away. In some workflows, there might be other long lived branches like the build branch or the release branch and so forth. But again, Git's lightweight branching model makes it easy to create and delete branches, as we'll see again in a bit, where branches are really nothing more than pointers to commits in the history of the repository. Couple of things to explore here in having the history of changes makes it possible to do all kinds of things that are sometimes necessary. For example, you might need to find the starting point of a commit. In the example I mentioned a moment ago, where a development branch exists for a long time, perhaps you've had to set it aside. And when you come back to it, you're not sure even where it started. Did it start from the main branch? Did it start from some other branch and branch off from there? And along the same lines, you might find a need to see all of the commits that happened on a particular branch. So if nothing else, you can refamiliarize yourself with what's going on, or might need to dig in a little more thoroughly. So one way to do that is to inspect the log or the log graph. The graph is a little easier to look at than the text log, but that's not necessarily the best way. So here's another tip. A better way is to use what's called Git's ref log. And that's simply a Git command followed by a branch name. Like all Git commands, you can get help for it by typing git help and the name of the command. In this case, reflog. And let's take a look at what that would look like. Here's an example. I looked for the reflog for branch one. This was a simple example. There were only 3 commits. They go from the most recent to the at, at the top to the uh, first one at the bottom. So we can see from the reflog for this branch that it was created from the main branch at commit 39154E1, which would allow us to go back to the history if we wanted details about where that was in the main branch history. So here's another tip. Reflog entries expire by default in 90 days. Ask me how I know that. This is a feature of Git's garbage collection. And I didn't know that this happened. And in fact, I had a uh, branch that had existed for more than 90 days, and I had to set it aside. And when I came back to it, I wanted to refresh my memory what was going on. I ran the ref log and I got several entries, but I never got to the beginning point. Well, again, as I learned later, because they expire in 90 days and Git garbage collection cleans them up, you can change that. Here's the tip. You can modify your global config file with a garbage collection entry called reflog expire, and you can set it to different values. 2 examples here. Again, if you want more information about this, I'd encourage you to go to the help for the reflog command. Another question that might arise is to find out what files were modified in a particular commit. So one way to do that is to say git show and then the commit ID, which works except that it also includes the diffs. And in command line Git, when you're not working with a GUI, that can get pretty hard to discern what actual files were changed. And you might not be too interested in the actual diffs, especially in a text format at that time. So let me go over to my command window here. And we're going to show that particular commit. So it's not going to jump out at you what file we're talking about. It's actually about 5 lines down where it says diff dash dash git and then datapath.txt. So this is the datapath file, but it shows not only the file name, but also the diff between the 2 versions of it. And there's more than one page of it. So we can go down to the end of the And that's the whole thing. That's the show for a commit. Not the easiest way to find out which file or files have been changed in that commit. Back to the slides for just a second. A better way is to use the dash dash name only option on the show command. And that does not include the diffs and lists only the file names. That looks like this. Much easier to see that in this case, 4 files were changed and which ones in particular. And I can actually do that in the command line here. And there it is. So that's a quick tip on how to use the name only option to quickly find out which files were changed. There are other ways, and we'll see those particularly when we get into the source tree section. So I think we have a minute here. Yeah, we have about a minute. If we have any questions, I could take them on this section right now.
No questions at this time.
Okay, thank you. No questions at this time. We'll go right on then. So next I want to talk about the VFPX Project Explorer. This is a really nice piece of work. This is on VFPX. It was developed and is maintained by Doug Hennig. It has many advantages, in my view, over the traditional project manager. Most importantly, for purposes of this session, is its ability to integrate with Git and Fox bin to PRG. And I'll explore how that works for you here in a little bit. You can install the Project Explorer via Thor, or you can download or clone it from the link, which is also in the white paper. You'll also find this listed in the projects page of vfpx.org, so you can get to it from there. I'll preface what I'm going to say here by saying that this is not intended to be a deep dive into Project Explorer. For that, I recommend you read the extensive documentation that Doug has provided with the product. What this is going to be for the next 5 or 10 minutes is, from my perspective as a user of Project Explorer, and I'll be talking about the way that I use it. I'll probably leave some things out. Certainly, there's a lot more to it than I'm going to cover here, but I hope this will give you an introduction. And if you're not already familiar with it or not using it, I hope this will encourage you to do that, because it really, for me anyway, has been a huge improvement in productivity and ease of use. So having said that, a little bit about how it works. Like the project manager, it uses PJX files. It actually runs the project manager in the background, although it's not visible when you're running the Project Explorer. If you look at the Windows menu in VFP, you'll see both Project Explorer and Project Manager. And in fact, if you close Project Manager, you're going to have to close Project Explorer as well. Where the Project Manager can open only one project at a time, Project Explorer uses the concept of a solution that can contain more than one project. So it's kind of like Visual Studio in that sense. The Project Manager or Project Explorer also uses metadata files, a DBF, along with a memo file and an index. And it uses an XML configuration file, which has got the name of the project followed by the .slx extension. Earlier versions used to use a solution.xml, but current versions use the .slx. And this file, among other things, contains the solution's version control settings. And I wanted to say that because it will become necessary to take a look at that in a little bit. How do you run Project Explorer? Well, one way is simply to do it from the from the command window. Project Explorer is an app, so you just do projectexplorer.app. If it's in your path already, you don't need the path to part. In default VFP, the MP command expands to modify project in the command window. So that's a real nice shortcut. I wanted something similar to that for Project Explorer. So I created an IntelliSense script using MX, which to me stands for Modify Project with Explorer, because MX is easy to type. It's similar to MP. It's easy to remember, and it was very easy to set this up. The script for that IntelliSense is in the appendix in the white paper. If you're interested, certainly free to use that as well. So you will see me typing MX at least once or twice, probably in the course of the demonstration today. So now let's jump into it. I know that first section was entirely slides. Slides can be boring. For the next couple of sections, I will flip over to the actual tools, Project Explorer and Sourcetree as we go along as much as possible. I do have slides for all of it just in case the demo gods weren't smiling for some reason and I was unable to access the tools. But so I'll be flipping back and forth between the slides and the tools themselves. So here is Project Explorer interface. Uh, you can see that it has a tree view down the side, which is a nice way of looking at it. And then off to the right, there are 3 pages for project settings, build settings, and servers. Let me see if I can get the actual tool up here. So here we go, and I'm going to type MX, and that will expand to the app, and there we go. So here again is our tree view. At the top, we have a drop-down list that allows us to select which node or nodes we want to see. On a small project like this one, and especially for demonstration, I'm showing all the nodes at the same time. They are collapsible, expandable, just as you would expect. If you're working on a large project, it's really nice to be able to focus only on the code or only on the classes, whatever your need is at the time. Over to the right, if we select whatever we have selected here will affect what you see on the right side. So if we select the project, then we see the project settings, and you can fill in the information as necessary, just as you would in the project manager. So all of this should be very familiar. It's just in a much nicer interface. When it comes to configuring for version control, and here's where the real beauty of this kicks in for purposes of this session, there is a solution or version control properties dialog where you can set up uh, which provider you want to use for both the version control and for the text to binary conversions, or binary to text conversions goes both ways. So let's see what that looks like in the actual tool here. And this is first going to open on my other monitor, so I need to drag it over so you can see it. So there it is. That's the same as what was on that slide. Now you may notice that the solution uses version control checkbox and the choice of Git as the version control provider are disabled at this point. That's because I already set this up. So once they're set, they can't be changed directly from Project Explorer. That's where the config file comes into play, and I'll see that again in just a minute here. But you still can change the choice of what to include, binary, text, or both, and you can change your choice of text converter. I'm going to cancel this out because I don't want to change anything. But here, by the way, if you do want the tool, gosh, this tool has so many powerful features. One of them is to automatically commit changes. If you want that to happen, mark that checkbox and then uh, choose your options here as appropriate. So I mentioned the configuration file. Normally, once you've set up the version control provider, you're not going to need to change it. But there came a time a few years ago when I did need to change it. And the reason was that when I first started using distributed version control, I used Mercurial. And I had several projects that I was working on, and I had configured Project Explorer to use Mercurial, which was fine until I decided to change to Git. And at that point, sorry, I had a little alarm going off there I had to silence. Um, So I found that I couldn't do that from within Project Explorer because those controls were blacked out as we just saw. So I couldn't do it from here. So I went into the solution file and I found the version control block, which is what I've grayed out here. And within that, I was able to identify the options for Git and for the text converter and for the choice of what to include and the auto commit. So in my particular case, which I'm sure was very unusual, I wanted to change from Mercurial to Git. Two ways to do that. I could have changed just the value of those settings within the version control block, or you could blow away the entire version control block, go back into Project Explorer, and reconfigure it from there. So a little side trip into the configuration file and why, at least for me, there was a time when I had to use it. One of the other super nice things about Project Explorer is that it will automatically regenerate the text file, assuming that you've modified the file from within Project Explorer. That can save you a ton of work and can also save your bacon if you were to have to do it manually and you forgot, then you might end up committing binaries with no corresponding text file. So the ability to do that automatically, I think, is really slick. Uh, Project Explorer does provide a way to do that manually if you ever needed to. Let me see if I can demonstrate that. For example, on a report, I can right click on a binary file and I can choose convert binary to text. And of course, you can go the other way if you're on a text file. So that's built into the tool as well. And finally, Project Explorer uses icon overlays to show the Git file status. In the slide, you can see here that the application, the project file itself, my app, is in a modified state. It has the red overlay icon, whereas the rest of them have the green check mark, meaning that they're clean. So looking quickly at the tool, and by the way, it's a little different in the actual repository here because in this one, this is a clean repository, but I can see, or a clean working copy, I should say. In this one, you can see at a glance that everything is clean. There's nothing waiting to be committed. So another nice feature of the Project Explorer. I skipped a slide there. Building the EXE, first of all, you want to go to the Build Settings dialog. And if you make changes there, it was important to point out that you need to click the Save button. Otherwise, those changes don't persist. And in order to actually do the build, you click on the drop-down build icon at the top, and then you get the build options dialog that you're probably familiar with. So that would look like this. Here we have the application, or the project file, I should say. Here we have the build settings dialog. I'm not going to change anything at the moment, but then clicking here allows us to build the project, or clicking here brings up the build options dialog, and we can choose all the familiar choices and then click OK to actually do the build. So this is really, again, a beautifully done piece of work. It's an excellent time saver. The integration with Git and Foxbin to PRG, to me, are two of the biggest selling points. And I hope that this brief introduction has done it justice and hopefully given you some incentive to explore this tool if you haven't done so already. So that brings us to the end of that section. How are we doing on time? We have a minute. Are there any questions about Project Explorer?
And not at this time.
Okay, good. Either I'm doing a good job or everybody's bored. So we'll find out as we go along. Uh, so now we're going to jump into Sourcetree, and we'll spend the bulk of the remaining time here. I'll try to leave about 10 minutes for the how to get in trouble and how to get out of it portion of the session. Sourcetree is a free Git GUI, graphical user interface client from Atlassian, which is the company that has provides Bitbucket and Jira and Confluence and the other developer operations tools. You can download it from sourcetreeapp.com. It's available both for the Windows and for Mac. And it looks like this for starters. And again, I'll be jumping back and forth between this and the tool, between the slides and the tool itself, hopefully to make this section a little more interesting. So let's see if we can get to actual Project Explorer, excuse me, actual Sourcetree. And here it is. So a couple of things to point out. First of all, it does have a dark theme, which I kind of like, but it doesn't show up well for presenting or as well. Probably not bad on your screen, but certainly doesn't reproduce well for the white paper. So I'm not using it here, but I personally tend to like dark themes. They're a little easier on the eyes, so you can choose that. Uh, Secondly, it has multiple tabs. So here I have 3 projects open. I have the current project for this session. I have a similar repository from a couple of years ago. And by the way, you might notice I have Project Explorer itself as a tab. I cloned Project Explorer, and therefore it's a Git repository, and therefore it has a remote because I cloned it, and so I can track it here and look for changes this way. So that's another nice feature of the Sourcetree interface. On the main menu, although it's not clear from here what the actual repositories are, you can look at repository settings and it'll tell you the name of the remote and the path to the remote. So in this case, I'm hosting it on Bitbucket. If you go to repository details, it'll tell you where the repository, the local one, is on your machine. So that's where this one is. Now, I would have expected that you could right click and change the names. You can't do that. That's all you get if you right click on a tab. You can change the names, but in order to do that, you have to go over here to what are called the bookmarks. And here's the one that I've labeled 2025. And if you click there, you get a rename option over here. So that's a little bit unintuitive, but you do have the ability to rename. If you don't rename when you open a repository for the first time, the name of the tab is the name of the folder, which in this case would have been my app for both the 2025 and the 2023 version, and that would have been a little confusing. So I renamed them. The workspace panel on the upper left is where you choose what you want to see in the rest of the interface. And there are 3 choices: file status, history, and search. We'll explore each one in a little bit of depth as we go along. The history view is kind of the default. The history view shows the graph history for whatever repository you're in and whatever branch you're on. So again, flipping back to Sourcetree itself, here we are looking at the, well, let me check out the main branch. You saw how easy it was to check out a different branch, just right click and check out. So here we have the graphical history of the branch. I'll go back to branch 2, check out branch 2. And I wanted to point out this drop-down list at the top, which says all branches or current branch. The difference is the order in which the graph is presented. In this case, we've checked out branch 2. The head of branch 2 is selected in the graph. If I go to current branch, that becomes the top of the graph, which makes it a little easier to follow down the history of that branch, at least the most recent commits. So you can choose whatever you prefer there. The checkbox for showing remote branches allows you to show them in the history. And over here on the left, you'll notice there's a section for remotes. And if we open that up, there's only one remote, which is origin. And within origin, we have several branches. These are the remote tracking branches I mentioned earlier in this particular example. There are several of them, some from the current session and some from a couple of years ago that I haven't pruned out yet. Well, they exist here in my local repository, but they don't show up in the graph. If I want them to show in the graph, I can mark the show remote branches, and now they all show here, or anything that says origin slash a branch name is a remote branch, a remote tracking branch. So that's another option. I generally work with that off. There's no particular need to see those in most cases. The other choice is the order in which you want to see the history. Date order is the default. That's all I've ever used. Ancestor order, I'm not really certain about. It seems to suggest that it would show it in parent-child order regardless of the date, which could be useful in some cases. Personally, I haven't explored that much. I just work with date order for the most part. So that's the first part of the interface. That's the history tab. I'll go back to the slides for just a minute. I think we've gone through most of this. And now we come to the file status view. The file status view, which in a clean directory looks like this, is where you will see the modified files. We will have examples of that coming up. At the moment, if you go to file status and look at this and see that there's nothing to commit, you know you have a clean working copy. So that's a nice way of quickly checking to make sure that your working copy is clean before, for example, you pull or change branches or do a merge or anything like that. There is one important thing about the um, file status view that I wanted to point out here, and that is the choice of which files to show. Uh, in this case, I'm working with pending as the default choice. The bottom section of that dialog is just the way you want to sort them. That's, of course, entirely up to you. Uh, so is the choice at the top up to you, but there are some differences that are important to know about. And here's the difference. Pending shows all new, modified, and removed files. So anything that's pending commit. Modified, on the other hand, shows only existing files that were modified. So that can be kind of a trap. If you work with modified, and you might at first glance think, well, that's what I want to see. I want to see my modified files. The trap is uh, two possible things can happen. If you add a new file and you're not going to see it in the list of unstaged changes. So that could be confusing. I mean, you know you added it. Why isn't it there? The worst problem potentially is that you would go ahead and commit, not realizing that the new file was not committed. And then you would think your new file is in the repository when in fact it is not in the repository. So I think suggestion is to work with pending rather than modified. Creating a branch is as easy as clicking on the branch button on the toolbar and then giving it a name. If I wanted to create a branch, again, I'll check out main and create a branch. I could give it a name here. By default, the branch comes off of the head of the current branch that you're in, and by default, the new branch is checked out. And what that means is that after you create the new branch, as I've done in this slide, I created branch one, so it is now checked out. You notice that it is in bold, and there's a difference that I want to point out here between the branch name being in bold and the branch being shaded background. The shaded background means that's the one you've selected in the list at the moment. The bold text means that's the one that is checked out, and that can make a big difference. Here's an example where the main branch is selected. I'm going to go ahead and zoom in on this a little bit for you. The main branch is selected, but branch one is checked out. Notice the difference. Not obvious at first, and maybe not obvious at all if you're working in a long list of branches. The one that's checked out, if it's alphabetically first, might even not be visible. So you might glance at the list of branches and think, oh, wow, I'm on the main branch because it looks like it's selected. No, it is selected, but it's not checked out. Whereas, in fact, branch one is checked out. So the tip is when you start working on anything, be sure you're working in the desired branch. If you start working in the wrong branch, as long as you haven't committed yet, you're still okay. But if you commit to the wrong branch, then um, you need to recover a little bit from that. So it's a good idea to always make sure you're on the branch you intend to be on before you start working. Now let's talk a little bit about the search dialog. The search allows you to search for three things. First of all, you type in a search argument, and then you choose one of the three things you can search for. And those three things are by commit message, by file, and by author. So this gives you a way of pruning down what you're looking at in the list, similar to other ways of kind of figuring out what happened. Let's see if we can demonstrate that here. I think I want to be on branch 2. And let's go to the search. And here I've done a search for demo 2 on the commit message. Let's get rid of the search and look at the history. We can see what else is there. Let's see who's made commits here. Bob, Alice, Rick, something called SW Fox Demo have made changes there. Let's see if we can search for Bob in branch 2 by looking at the author. Yep, there we go. There's everything that Bob did over here. So that's kind of a nice way. The commit message one, actually, that I showed a minute ago, uh, looks at it's a partial match on anything in the text, which includes the branch name. If you're working on an organization that uses a task tracking, you might have a standard procedure that says include the task number or task name in the commit message. That's another way of filtering it out. And finally, the ability to look at changes to a particular file can also be useful here. So there's a file called datapath.txt. I don't need to type the .text part. It's a partial search. Then I can search on file changes, and I can see all the changes that affected the datapath.txt file. And again, if you select any of them, any of these search results, you're going to get the list of what was committed at that commit. And if you look at the file that you searched on, you'll see what got changed or added there. So that's the search panel. The next three slides are just what I showed you, so I'm going to step right through those. And now we come to the question of how to run Fox bin to PRG manually. As we saw earlier, if you are using the Project Explorer, you can use the context menu that's built into Project Explorer and run Fox bin to PRG directly from that. So that's super nice. If you are not using Project Explorer, Fox bin to PRG comes with an optional way to hang the commands on the File Explorer Send To menu. That looks like what's on the slide here. You have to do that, but it's simple to do, and the instructions are included in Fox bin to PRG's documentation. So another way to do it would be to move to File Explorer, right-click on a file, Send To Fox bin to PRG. To me, that really breaks you out of your workflow. My workflow, maybe yours as well, revolves around being in FoxPro most of the time, being in Sourcetree pretty much the rest of the time. And when I'm in Fox, I'm in Project Explorer. So I really don't want to back out and go to File Explorer and hunt for a file. But the other way to run Fox bin to PRG manually is to create a custom action in Sourcetree. So if anything is going to pay for your hour and 15 minutes at the session today, I'm going to suggest that maybe this is it. So this is your tip of the day. You want to create a custom action that runs a program. In this case, you want to run foxbin to prg.exe along whatever path it happens to be in on your machine. I'm going to actually go over to Sourcetree and show you this because the dialog will be a little bigger than it is here. So we're going to go to, it doesn't matter which of these you're on, Tools, Options, Custom Actions. I've already built this one, so it exists in the list. So I'm going to select it, and rather than adding a new one, I'm just going to edit this. So here's the command. You give it a caption. That's what's going to show up on the context menu in Sourcetree. You have a couple of options here. In this case, I don't need to see it, so I just run it silently. The script to run, again, is the path to foxbin to prg.exe, which in my case happens to be the one that I installed from Thor in this particular example. And then the parameter You have four choices. In this case, we want to pass a file name, so we pass the $file parameter, and I'll just cancel out of that. And then to run that, it's as simple as clicking on the file that you want to run it on, choosing custom actions, and then clicking Fox bin to PRG interactive. Fox bin to PRG, as I'm sure all know, is smart enough to know which way it needs to go, binary to text or text to binary, based on the file extension of the file that you clicked on. So let's see if I can actually illustrate that in Sourcetree. One challenge here, by the way, is what happens if the file that you want to operate on is not visible here? Well, you can go to the history. You can look for a commit that modified that file. You could use the search like we did a minute ago. But there's another way, and that's what I wanted to show you in file status. Rather than pending files, we can tell it to show all files. And now every file in the entire project that is tracked is listed here. They're all green at this point because there are no unmodified, but at least it allows me to find it in the list. So suppose that I wanted to operate on the report file and I wanted to go uh, binary to text, custom actions, Fox bin RPG interactive. I'll go ahead and run that. Probably won't make any change because Fox bin to PRG knows that it's the same as the one that's already there. So it didn't change it, but that's as simple as it is to do it from within Sourcetree. And what I like about that is that it doesn't break you out of your workflow. You're in Fox, you're in Sourcetree, you're in Fox, you're in Sourcetree, back and forth all day long during your development work. And without having to go back to File Explorer or anything else, you can, if necessary, create those binaries or create the text file directly from within Sourcetree. So that's what a custom action is all about. One tip here is that Foxbin to PRG cannot run if the file is open. That's true not only of the project file, but any file that it needs to operate on. So here's the mistake that I always make. I almost always have the project file open in Project Explorer in Foxborough. I then forget that I have it open and I go over to Sourcetree and I try and do an operation that involves something with the project file. And I get an error message saying, oops, can't do that because it explains why. But it becomes obvious that it's because the project file is open. So Fox bin to PRG cannot operate on it. So the tip is always close the project file in VFP, before you try and do any of the Fox bin to PRG operations on it. Let's move on to making changes now. If you change a file, it shows up in the unstaged file area at the bottom on this slide. In order to stage a file, again, this is basic Git, but this is how Sourcetree does it. You have a stage all or stage selected. You can select one or more files in that list of unstaged and select them individually or as a group. You can also use the little plus icon on the right. And when you stage files, they then jump up to the top in the stage files area. And in the same way that you could stage them, you can also unstage them all at once or selected ones or just a single one. And you can also use the minus icon on the right there, which does the same thing. After getting everything the way you want it, in this case, we want to commit, we're getting ready to commit all three of those files. Then we want to go ahead and do the commit. A couple of ways to do that. There is a commit button at the top on the toolbar. I generally use the commit area at the bottom. Let me make that a little bigger for you. And this is the area in Sourcetree where you type in the commit message, in this case, update report file or report title, and then click the commit button, and then it does the commit. A couple of other options at the bottom. In the center, the amend latest commit. That's what you would check if you want to amend the most recent commit that you did, adding a file, removing a file, changing the commit message, and so forth. Pushing changes immediately is a choice. I typically don't work that way. I prefer to push when I'm ready. Sometimes I'll push multiple commits at the same time. So personally, I don't use that option, but it is there. Couple of options that are nice to know about here. I'm gonna back up one couple of slides. In this case where we were looking at unstaged files, suppose I wanted to commit only one of them. Doesn't really make sense in this example because they go as a unit, but if I did, the default behavior of Sourcetree is to go back to the history view after the commit has been done. If there are still uncommitted files, it's kind of nice to be able to stay in the file status view so that we can see that. And perhaps we wanted to break it into two commits uh, in that same group of files. So the way you do that, and again, I'll jump ahead to the slide we were on a minute ago, is with this option. So this is in the general option. I think it's probably going to be easier to see if I actually go to Sourcetree. So tools, options, general, and then down here is the after committing, stay and commit dialog if there are still pending changes. So I like to work with that one because that way I stay in the file status dialog if there's anything left to commit, so I don't forget that I might still want to commit other choices. The other option that's interesting here is the size limit for text files. Sourcetree cannot know all of the file extensions that there are in the world for binary files. So it uses a size limit. By default, that limit is 1 megabyte, 1024 KB. And if it ever happens that you are working on a large text file, like a large PRG, and you've made a change and you look at it in Sourcetree and you try and inspect the diff, which is what you get on the right when you select the file in the unstaged files area, it might say it's a binary file, can't diff it. Well, that's confusing because you know it's not a binary file, it's a PRG file. And the reason that can happen is because of that size limit. So if you set the size limit to something other than 1024, like, you know, 2048, 4096, it doesn't have to be an even multiple of megabytes, I think, but it can, whatever you want it to be, will instruct Sourcetree to treat that as a text file in spite of its size, and that way you can, in fact, see the diff. Often in our development work, there are going to be changes that pop up in your unstaged files area that you don't want to commit. This is true especially in Foxborough because Fox, when you build a project, will regenerate the MPR files. It might make internal timestamp changes to some of the binaries that are really irrelevant and don't need to be committed because it just clutters up the repository. So it's easy to discard file changes. Again, back to the tool. If we look at the file status for pending files, I guess in this case we didn't have any. Maybe on, oh, I know it's over here. There we go. I've got a couple of unstaged files here. If I wanted to discard those file changes, right click, discard file changes, and that just reverts them back to whatever their previous state was before modification. That's different than remove. Remove means to actually stop tracking them, remove them from the repository. So you want discard file changes if that's in fact what you want to do. Pushing to the remote is as simple as using the push button. Sourcetree provides icons, overlays to show that there are pushes pending. It does the same thing for pulls. In this slide, the one that shows up on the push icon, make that a little bigger for you, means there's one commit pending a push, and the same icon on the main branch down below means that the commit that's pending is on the main branch. So if you click the push dialog or the push button, you get the dialog. What branch do you want to push? By default, it's going to be the branch that's checked out if it's already been pushed. If it hasn't been pushed, then you'll have to mark it. And if it hasn't yet been pushed, it won't have a name here. But as soon as you push it the first time, it creates a remote tracking branch of the same name. And then the name will show here. And by default, it's being tracked, meaning you have a remote tracking branch. Pulling is the opposite of pushing. You select the branch you want to pull into, you click the pull button, you get a choice, which really just confirming which branch you're pulling from and which branch you're pulling into. The checkbox immediately below the red area there says commit changes immediately. That's an option, but typically I think you're going to want to do that. I'm not going to talk about fetch here, but fetch is the sort of the first half of a pull operation, which updates the remote tracking branch without actually merging. So you can use that if necessary. You can merge, again, back in the local directory now, if you want to merge two branches together, at least two ways to do it. One is to click the merge button, and that brings up a dialog that looks like this, where you can pick the branch to merge into your current branch. That's actually what it says here, but it's really hard to see. Pick a commit to merge into your current branch. Well, to me, that's not the easiest way to do it. To me, the easier way to do it is to use the list of branches on the left to select or check out the branch into which you want to merge, and then to right click and select merge branch into current branch. Again, I can illustrate that, I think, here. If I wanted to merge, I'll check out branch one, then I'll select. So here's a case where branch one is checked out, branch two is selected, and I'll click merge branch two into current branch. That's already been done. You do get a confirmation, so I'll just say no, but uh, that's how you would do it from the right click menu. You get a merge confirmation dialog like we just saw. If there's a conflict, you get this dialog, you have to resolve it. The file that has the conflict shows up in the unstaged file area. In this case, it's the PRG file, and the difference is shown on the right. Git uses the concept of mine and theirs when it comes to merge conflicts. Mine being the one that's in the branch that you're merging into, theirs being the one on the branch that you're coming from or merging from. So there's a couple of ways to resolve it. You get this little pop-up menu. You can either launch the external tool to change it manually, or you can resolve using mine or resolve using theirs. I explored restart a little bit. It seemed like it was more trouble than it was worth, so I am not going to get into that, partly because I don't fully understand it. But I've never had to use it, I can tell you, in all the years that I've been working with this. So here's what that tool looks like, or what that menu looks like again, where mine is the target and theirs is what you're merging from. In this case, I chose to resolve it externally. The thing I wanted to point out on this slide is the commit message. Sourcetree supplies that commit message for you, except for the words on the second line after the word conflicts. So that's your opportunity to explain a little bit how you resolved it. For example, resolved using mine, resolved using theirs, or in this case, resolved by creating an entirely new solution for it. You can also choose log selected. We're running a little short, so I'm not going to show that. But if you look at any file in the list, you can right click and choose log selected. That brings up a dialog like this that shows you all of the commits that affected that file. So another nice way of exploring history. We really don't have a minute here, so if you can, I know this may have generated some questions, but if it's okay, I'm going to go right on through. We may have time at the end, and there is a Q&A session for 15 minutes following, and I'll be happy to take questions there as well. So in the time we have remaining, which is just about 6 minutes, I'd like to explore quickly some ways that we can get into trouble and ways that we can get out of it. If you make a commit that you don't like or wanted to change, you can amend that commit. I think I pointed out that amend latest commit box at the bottom of the commit message in Sourcetree. Again, if you omitted some files or included some you did not intend to include, or you wanted to revise the commit message, you can amend the commit. The rule here, and this is Git's rule, not Sourcetree. It's not a rule, but it is a highly encouraged guideline. Never amend a commit that's already been pushed. Why? Because somebody else might have pulled it already. You don't know that. And if they pulled your earlier version of your commit and then you amend it and push it, now that can cause problems for the other person down the line. So that's a rule of thumb. Deleting a branch is extremely easy. Just remember you cannot delete a branch if it's checked out. It'll also warn you if you try to delete a branch that has uncommitted changes, but you can force delete if necessary. And deleting a branch in Sourcetree is as easy as clicking on it and choosing delete from the pop-up menu. If you forget the text equivalent files, it can have repercussions. Again, that's where Project Explorer to me is such a sweet tool because it'll do that for you. It'll create the text equivalents for you if necessary, as long as you've made the modification from within Project Explorer. So, for example, if you forget it, what can happen is you might not have a text file for resolving merge conflicts, or maybe even worse, if you forget to commit the text file, and then somebody else pulls and regenerates the binaries from an older version of the text file. Now they have an older version of the binaries, and they probably have no idea that they're missing something that actually was supposed to be in there. So, my rule of thumb there at the bottom is when you're looking at the unstaged files and you're dealing with binaries, you should always treat the pair of binaries and the text equivalent as a unit. If there is no text file and you think there should be one, regenerate it. I showed you how to do that from within Sourcetree. So it's an easy step. If it doesn't create one, it means the new one is the same as the old one. If it does create one, it'll pop up in the unstaged files area and you'll be able to work with it. Sometimes you just want to bail out of a merge. You can't tell how to resolve it. You might need to talk to the other developer and touch base and determine mutually how to merge the two code bases before you proceed. In that case, you just want to bail out of the merge. Sadly, I don't see a way to do that from any menu in Sourcetree, but you can easily abort a merge from the command line with git merge dash dash abort, or you can just do a hard reset. Either way, you get back to uh, the state before the merge began. And the last one is where you think you've lost some code. The situation here is that you're working along and you know you've made some changes. You know you've committed them. You know you pushed them. You know they got merged. But somewhere along the line, you realize the code is no longer in the remote and it's no longer in the local. And so what do? I mean, it looks like your code is just gone. If it's not in the local repository and it's not on the remote, how do you get it back? Well, do you have a backup? What I call an off Git backup, not off site, but off Git. In other words, somewhere outside of the Git folder, your project folder, like a temp or a work folder or something. If you have that, and by the way, not necessarily a bad idea to have that, then you have a way out. But if you don't have that, how do you recover? Well, here's a situation where this actually happened in an scenario that I'm familiar with. Code was modified and pushed, pull request was created and merged. I'm skipping a step here on purpose because I'll come back to that. Um, you pulled from main and merge main back into your local branch. In this workflow, that's the way you get changes back from other developers or even from your own pull requests, is to pull from main and merge into your local branch. And suddenly you look at your local branch and your code is lost because unknown to you, step 5 happened. The merge that included your pull request got reverted on the remote before you pulled. You didn't know that. So you went about things in the standard operating procedure, but you find out your code is lost. Well, if you have that backup outside of Git, that's one way to get it back. The other way is remote tracking branches, which again are branches in your local repository. And as long as you haven't pruned it, your remote tracking branch still has your code, which you can check out. That looks like this. Again, make that a little bigger. If you go to the remote section of the list on the left in Sourcetree, you'll see the origin, most commonly called origin, and then all of the branches. You can select a branch and check it out. When you do that, you get a dialog that says, what's the new local branch? Typically, you give it some meaningful name so you can differentiate it from the original. And then you go ahead and do that. Let's see, I need to be here. Sorry. I don't know what happened to my slides. Not seeing my slides. Well, that's frustrating because we're right at the very end here. Let's try slideshow from current slide. There we go. Sorry about that. Anyway, what you end up with is another branch that is your remote tracking branch. Now it's actually in your working copy, and you can compare the two, make another backup, do whatever you need to do. So that's how you recover. Now you can celebrate you got your code back. And to finish up, because we know we're out of time, and again, I'll take all questions in the Q&A session. We reviewed the workflow, or at least the workflow that I'm using here in Git. We talked about Project Explorer. I hope I got you a little bit excited about that. We spent quite a bit of time in Sourcetree, specifically on working with Visual Foxborough and Git. And hopefully there was some value in the little section here about how to get out of trouble if you find yourself in trouble. Usually there's a Git solution, but a off Git backup is not a bad idea in every case. So please fill out your evals. I appreciate your time today. All the contact info is in the white paper. I will see you in the Q&A session, and I think we are done.